Hello, let's talk some more about sequences and series. Now, in the Module 7 discussion, 168 is not the total earned as a grocery delivery worker. So what does that 168 represent? Let's look at the formulas. For an arithmetic sequence, a sub n represents a term, the nth term. A sub 1 is the first term, d is the common difference, and n is the term number. So a sub 60 would represent the 60th term in the sequence. A sub 60 might turn out to be 168, which means that's the pay on the 60th day, not the total for all 60 days. If it's a geometric sequence, a term, a sub n, the nth term, would represent a particular term. So a sub 13 would be the 13th term. That would be the pay on the 13th day. How much you would earn on day 13 of a geometric sequence. A sub 1 is the first term, the r is the nth term, r is the common ratio, and n is the term number. These are the formulas to sum a series. If it's arithmetic, take the number of terms divided by 2 and multiply it by the sum of the first and the last term. If it's geometric, the sum of the first n terms is the first term multiplied by the quantity 1 minus r to the nth power over 1 minus r. We need to consider the sums when we're taking a job. Not how much do I get paid on one day, but how much do I get paid over the course of my time. So let's look at some ways that we can use these formulas that will show up on your worksheet, where it uses the formulas, but perhaps a little bit differently. So the sum of the first 50 terms of the arithmetic series that begins with a 7 has a last term of 301. Well, we know there are 50 terms. The first term is 7, and the last term is 301. We're told it's arithmetic, and so S of n equals n over 2 times a sub 1 plus a sub n would be our formula. Plug in our values and do our arithmetic. Pretty straightforward. So there are 50 terms from 7 to 301, and their total, when we add them, is 7,700. Find the sum of this arithmetic series. Okay, it's arithmetic, same formula. 4 plus 12 plus, and it goes on to 804. We know the first term is 4. We know the last term is 804. We know the common difference is 8. But when we look at our formula, we need to know what is n. So if we take a look at our term formula, a sub n equals a sub 1 plus n minus 1 times d, we see that we know 3 of these 4 variables. A sub n is 804, a is 4, and d is 8. We plug those in, subtract 4, divide by 8, and add 1. So n is 101. We can now go back and find the sum. So our sum is 101 divided by 2 times the quantity 4 plus 804. 40,804. So even though we don't know all the terms and we didn't even know how many terms there were, because it was arithmetic and we could determine the common difference, we could find the value for n. Now, taking a look at another example, the first term of a geometric series is 5, and the 8th term of the series is negative 640. What is the sum of the series? Okay, so it's geometric. The first term is 5. There are 8 terms, and the 8th term is negative 640. For us to find the sum, we need a sub 1, r, and n. When we have a sub 1 and n, we need r. So we step to the side. We know that the 8th term is equal to a sub 1 times r to the 8 minus 1 power from our term formula. Negative 640 equals 5 r to the 7th. So when we divide by 5, we get negative 128 equals r to the 7th. R is equal to the 7th root of negative 128. Time for our calculator now. And remember, you learned earlier that to take the seventh root of something is the same thing as taking that number to the 1/7th power. Just like taking the fourth root, raise it to the 1/4th power. You could also put a seventh root in with a radical notation, but it's usually easier to raise it to a fractional power. R turns out to be -2. So the sum of our first 8 terms is the first term 5 times 1 minus -2 to the 8th over 1 minus -2. 1 minus -2 to the 8th happens to be -256, and 1 minus 256 is -255 divided by 3. The sum is -425. So since our ratio was -2, our first term was 5, our next term was -10, our next term was +20, then -40. So we can see how we're going from positives and negatives. Now it's possible to end up with an overall answer that's negative. Please be very careful on the worksheet involving series and sequences. You'll use the formulas, but it might not be the case of where the unknown is on the left. The unknown may be one other piece of the formula. See you in class.